Welcome to our audience members to the May 2024 Tech Talk, the AESIN Tech Talk. This is our monthly Tech Talk session where we invite members and affiliates of AESIN to come and talk about innovation and what's happening in the industry that's really pertinent for us all. I today have the pleasure of having Saket Mohan with us. Saket and I have been working together for the last few months on topics around generative AI, and in particular, a project looking at how we apply generative AI in automotive product security development. Now, I'm an old fellow now, and so the topic of AI and generative AI is starting to is starting to stretch my experience and knowledge as well. But it's fascinating how this world is going to move forward. And when I got to see what Saket was doing in this project, it blew me away as to the possibilities of what we can do within the automotive industry. So when Saket offered to present at the Tech Talks, I bit his hand up and said, "Yes, you're going to come and talk about what we're doing in this project." The topic of today's talk is revving up security, integrating generative AI in an automotive product security lifecycle application to navigate UNR 155, which is a hot topic at the moment. The industry is really grappling with this, and there's some interesting insights that we're going to hear about today to lead us to what the next generation might well look like. Saket himself has a huge experience in the industry around these topics, and I've known Saket for a few years as well now. And this new initiative, the Secure Elements part of his life, is coming at the right time to really talk about what we can do in the UK. So without further ado, Saket, I'm going to hand over to you. Please feel free to share slides, maybe a few seconds to introduce yourself, and then let's go for it. I will ask the audience to hold your questions. Feel free to put them in the chat as you see them. Chris, who's supporting me, will also prompt you at an appropriate time during the call to ask you to pose questions as well. So Saket, stage is all yours.
Okay, thank you. Thanks, Gunny. So let me just quickly share my screen. Can you see my screen?
Yes, we can. Yeah.
Okay, perfect. Okay. Okay, so yeah, good afternoon, everybody on the call. My name is Saket Mohan, and I am the founder and CEO of Secure Elements. So we are an automotive cybersecurity software company, and we are building tooling solutions to help navigate the challenge of cybersecurity, within the automotive space, mainly driven by the UNON R155 regulations and the ISO 21434 standard. And I'll talk through some of the details over the course of the presentation. But it's important to highlight that yes, thanks to AESIN as well to be a part of this journey, that we conducted this experiment, some kind of feasibility study to understand where are the applications of generative AI and how could it be used to leverage some of the manual labor that is currently going on in the cybersecurity automotive space, particularly around risk assessment, security operations, etc. So my talk will go through mainly 5 stages. A bit of introduction on the company, some guidelines around automotive cybersecurity standard and regulation for people who are not familiar on the call with these. We then take a look at 1 or 2 slides around the current state of art or the cybersecurity TARA current ways of working. TARA is threat analysis and risk assessment. And then we go into the details of application of generative AI in that TARA in some aspects. And I'll also try and share some learnings, what we have got from initial model training. And finally, we'll open up for questions, answers. So that's where we are at. So, as I said, I founded the company. So I'm the founder of the company in 2022. And our mission is to drive safe and secure adoption of technologies for future mobility solutions. And we are building critical engineering tooling solutions, mainly around two aspects. One is fulfilling the lifecycle application requests. So currently there is a huge demand in this segment for a tool like us, for a company like us to provide these tools to perform risk assessment, vulnerability management, and all the good stuff that come in the area of cyber real. And then the other aspect that we are currently working on is the Mobility Security Operations Center, or call it a security operations or a vehicle security operations. There are many words going on in this space. So we are dedicating ourselves to creating these tools, and I'll show you a glimpse of this as well throughout the course of the presentation. So when I said safe and secure, is not just meaning safe and secure. We actually do this systematically using a systems engineering fashion in our tooling solutions. So we bring along, I mean, pretty much everybody on the call will know that we follow the automotive V cycle to the best of our ability, where to design safe and secure systems. But because cyber has been recently added to this V with the recent introduction of ISO 21434, and majorly driven by R155. Our platform, our software solution, which is purposefully built, takes into account the system artifacts, the safety artifacts, and the cyber artifacts all at the same time. So we perform system modeling analysis. At the same time, we also perform functional safety analysis, part 3 of ISO 26262. And at the same time, we also perform cyber analysis to make sure that all the engineering artifacts and analysis are done at the same time, and which is why we call it an integrated product, bringing all the three domains together so that one domain is not isolated, because isolation will lead to inconsistent requirements across different domains, and therefore will lead to different requirements, and therefore will lead to different development cycles. So this V cycle actually summarizes very nicely as to how Secure Elements is trying to bring, one of its product suite called CRISKLE, all the elements together to satisfy some of the emerging needs in this space. Right, a bit of, obviously not delving deep into this, but yeah, as we transition into this software defined vehicle concept, with more and more features being driven, let's say flashed remotely on the car using OTA technologies, and mainly around around increased level of autonomy, that will drive the necessity to have cyber secure systems in the first place. I mean, not doing so is, obviously ending up leaving your systems more vulnerable, but in obviously putting both the passengers, occupants, but also the business makers, the automakers, at significant risk and disadvantages. So I've also put some information around the recent cybersecurity attacks and some of the headlines making articles in recent times. So it all started 2017, as recent as 2023, to the best of our knowledge, where we have seen limited, or let's say confined, attacks by security teams to basically perform an attack on a Tesla or a Mercedes-Benz. But equally, there are there are regulations, incoming regulations, and particularly around US and how UK is viewing these kind of threats, because it's not just limited to threats on the critical national infrastructure, but because vehicles are a part of that critical national infrastructure, that actually drives the demand for these type of technologies and solutions to actually enable those things. Going back to the point of regulation, so I think many of you on the call, and if not, then UN R155 is the latest regulation for automotive that specifies a set of requirements to be fulfilled, and not doing so will lead to penalties, mainly around you not being able to sell those cars in the local market, or rather in international markets in those applied regions. Obviously resulting into mainly financial damage for that automaker, but equally it's a loss to the customer at the same time, because they don't get to choose a safe and secure vehicle. It's an operational loss in case a cyber attack actually happens. And of course, we are putting pretty much all our lives at risk in terms of safety, but also data privacy aspects. So putting the SDV concept, putting the overall regulation and standard into one slide, there we created, we analyzed the status quo of the industry as of today, and the tools which are available as of today to help engineers like myself and like yourselves to conduct these type of assessments, experiments. There is still a very large gap to fulfill. These numbers are a true reflection on the state of or the status quo of the industry, particularly if you look at the technology and tools availability. It is still very sparse, and these numbers are true till 2023. I mean, this is December 2023, so we are only 4 and 5 months ahead. So 31% of the participants who participated in all the four surveys as listed above, um, still, there is still a large gap to actually fill this space of tools and technology. Coming to the whole aspect of generative AI. So yes, it's not only a buzzword, but I'll take you back 2017 to 2018 when we had this kind of hype cycle around digital security solutions, where when we were starting to discuss 21434, particularly around automotive. And I was fortunate to be a part of that committee as well through my earlier organization. It's interesting to see how time has passed, and we are now approaching a plateau of productivity in terms of adoption of cybersecurity management system. And equally, the same applies to an introduction of generative AI. So if you look at the right side of the Gartner hype cycle, we are still at the bottom here, exploring the feasibility of generative AI in security assessments, set security operations. But still, there is a significant gap between what we are doing today and the plateau is expected to reach around, in about 2 to 5 years' time, which actually indicates, taking the example of how 21434 went from its concept, let's say draft phase to its implementing state now. I think we'll be following a similar sort of pattern over here in terms of adoption, because bear in mind that it's generative AI, and therefore it's not just a direct one-to-one mapping into any risk assessment tool, but you have to be cautious and careful in terms of its applicability, its usage, its safe and secure usage at the same time. So therefore, yeah, I mean, it's still an innovation trigger. So for the purpose of today's presentation, we'll be mainly focusing on the 21434 standard, clause 15, particularly, which is around TARA, which is the threat and risk assessment, as highlighted in green. So the problem that we undertook, or the scope of the work that we undertook to understand, okay, we do TARA assessments today. That's already a drawback. We shouldn't be performing our risk assessments in Excel anymore because it's not feasible, but at the second time, it's laborious, it's time consuming, and it will lead to non-compliance at some point in time, even though organizations will go for type approval today and tomorrow. So in the longer term, that is not a practical solution. Secondly, as all of you know, we are experiencing lack of experienced labor especially in the UK. So system professionals, cybersecurity professionals, safety professionals are very less in numbers. So lack of experienced professionals to conduct these assessments, people who generally appreciate the understanding of systems engineering, because a cybersecurity professional has to be the one who understands a bit of safety, a bit of systems, and also cybersecurity. Because otherwise that will lead to catastrophic outcomes and security requirements being driven. But that is how the state of the industry is as of today. And again, going laboring the point of significant labor and human effort required, because you're not just conducting this TARA assessments on one ECU or two ECUs, but there are more than 60 or 50 ECUs on a car. And then you can multiply that by the number of car lines and then times it by the number of OEMs. And this is an exponential rise. So therefore, you need some kind of automation, some kind of an AI that would help you conduct these tests, these type of assessments. So using the current state of art of TARA, the TARA is a static document. it's fixed with a number of scenarios. There are inbuilt inherent scenarios from the regulation 155, which is often taken as a very, very standard baseline, merely because everybody wants to comply. And there has to be a step forward at some point in time. It is laborious. It only addresses the bare minimum to basically comply. So overall, leading to an incomplete set of documents, resulting in greater exposure because a wide array of assets or maybe the whole systems consideration has not been done, therefore leading to wider attack surfaces and of course, increased vulnerabilities. So clause 15 of ISO 21434 defines a series of steps. Um, and we'll be mainly focusing on the two areas. One is threat scenario identification and risk treatment decision, where we undertook this study to understand how can generative AI be explored or be integrated or be applied to these two sections mainly to first of all expedite the threat scenarios generation, because and moving beyond the minimum set of baseline, but still keeping it aligned to the systems engineering, because what we don't want to do is end up generating scenarios which are not systems or context driven. So we'll take a look at that. And then secondly, once you have applied generative AI to generate these scenarios, can the same logic be also applied to map it to a risk treatment decision? A quick example could be a requirement for um, let's say a MAC authentication, and a risk treatment decision will be to implement some cybersecurity controls like OpenSSL or any other cyber suites to basically control that risk. So we'll closely look at these two aspects over the next set of slides. So what we did was we took an open source data set. Its name is called ROAD. It's the automotive dynamometer based data set, mainly on CAN. It's a CAN data set, consists of 13, 13 different runs, has inclusion of more than 100 ECUs on it. And it's a 30 minutes dedicated recording, and it has many different types of attacks, but we mainly focused on fuzzing and spoofing just to understand how can we implement some of the new algorithms from the generative AI space to understand the next sequence or the CAN ID sequence. So this is the base model that we came up with in a simplified manner, wherein you have the CAN data frame that we obtain from the CAN logs, has a CAN ID, of course. And then we study the bit sequence, and we then push the bit sequence, so the CAN ID into BERT, which is a generative AI, let's say a natural language processing algorithm. But then not exactly BERT, but we use something called a sentence pair modeling or a sentence pair technique, wherein IDs are acting as keywords, and then we predict what's the next logical keyword against it. A simple example is if I give you a sentence comprising of several keywords like A, B, C, D, E, and if I were to tell you to join them together logically in sequence, you will do A, B, B, C, C, D, D, E, and so on and so forth. Logically, applying the same principle on CAN ID, if we feed the respective CAN IDs to this model on this data set, we were able to identify the next upcoming CAN ID in the CAN logs and then predict the next logical anomaly. Again, just to mention that this data set was pre-trained on certain types of attacks. So we had nothing to do with labeling. The data set came pre-labeled, and therefore that helped us to directly go about implementing or implementing the sentence pair modeling technique as part of the BERT series of algorithms. The next thing that we did was using our platform called CRISKLE, we generated a use case of a full Tara, and then we fed in some threat scenarios through our application into this model. And then we were able to, let's say, to predict or to pick up what was the next logical CAN ID sequence from the CAN data. So basically, it's a set of benign data being fed to understand the next logical CAN ID sequence, and then basically generate outliers. So the outliers will be pulled off, and and the next logical attack sequence will be put together as an anomaly. This was a very, very uh, kind of a high level. This is a very high level diagram to give you an appreciation, understanding of how the whole model was split between two areas. One was threat scenario injection, and one is the determination of the attack based on using BERT on the CAN logs. That's the sequence. So you have the CAN data frame, then you have the CAN ID. Um, then you can derive the CAN ID sequence out of it using the same sentence pair modeling technique. And then you feed that into the LLM or the BERT to predict the next sequence of that anomaly or the event. And then basically derive, capture the ID as to, and then, basically tell that, okay, this anomaly is this particular attack scenario based on the raw data set. Right. So when doing so, when doing trial one, using that particular model that I just discussed, um, we fed in the threat scenarios, as you can see on the screen. These threat scenarios were written in Jupyter Notebook using our CRISKLE application. Um, it was able to derive some context, but it was not complete in its entirety. A good example is, I fed in, we've actually fed in an attacker disables the eCall functionality. And then it generated some random text which had no meanings at all, based on the anomaly it detected from the CAN log sequence or from the DBC files that we fed in. So firstly, meaning that it needed some more, let's say, polishing or some more looking after. So as an output of trial one sequence, incomplete threat scenario generation, random in nature, and no context. The next one we did was we basically analyzed the group of LLM BERTs currently out in the market. Obviously, GPT-4 refined is the latest and the greatest one, because this study was done in the month of January, February this year. So obviously, at that point in time, the latest and the greatest one was GPT-4. Then was Claude and GPT 3.5 Turbo Instruct. So mainly we focused on a GPT 3.5 Turbo Instruct. Downloaded the whole data set of Hugging Face and in our local machines, to make sure that we are not sending any proprietary data or any data towards OpenAI server. So downloading the whole data set, the whole model of 12.5 gigabytes, storing that, and then implementing this method of analysis was done purely on our machines, to prevent any privacy related concerns or any IP sharing. Having done so, we analyzed four different models. So OpenAI was basically customizable. It offers huge customization. So you can download models, you can play with the models, change. The same was not applicable to Llama and Claude and Gemini from Google. It had some limit. So all of the models have some kind of limitations as against OpenAI, mainly around GPT 3.5. So we took GPT 3.5 as our baseline then again, and then we reran, we created a new sequence of events and a new model to perform trial two. So this time we fed in some user inputs to the OpenAI library setup. Obviously, we enabled a prompt, so proper prompt as an input text that would go into the OpenAI system. Using the API request. And then in addition to the GPT 3.5 turbo model, we introduced a new technique within the BERT family called as retrieval augmented generation. Now, RAG is a relatively new area of generative AI, introduced in late 2020s by an ex-Facebook engineer. Now, this concept or this type of technology actually uh, uh, looks at meaningful data from the internet, to make the model much more accurate. Because remember one thing, that GPT 3.5 was trained um, at some point in time and was cut off, so it has no knowledge of today's day and age. The training model was cut off, I think, as of February last year. So to enable the current, let's say, the general knowledge of that GPT 3.5, we then used a concept of retrieval augmented generation that would go out in normal public internet. So we are not touching anything on the model, but rather we are doing the application level search on World Wide Web to scout for more information to make the model much more, and to basically enrich the model. And then that gave us some outputs. Now, using this method of RAG, when we reran the whole scenario, uh, firstly, we were able to generate meaningful scenarios. So we first of all generated one scenario, threat scenario, uh, and this time the results were complete in nature. So the English, or the concept of hallucination in AI models, that was not there. So that ambiguity was not there. It was complete in nature. And second, because we used system context data, and I'll show you in a minute what system context data did we actually feed in. It then gave us not just one, but we were able to change the system parameters, and it was able to then give us 10 more, hundreds more threat scenarios. Now this is quite an encouraging study, which actually meant that if using this technology, rack generation plus the BERT sequence to understand attack detection patterns on CAN logs, can derive meaningful threat scenarios, we could then validate this model against UNR155. Uh, so meaning that we then undertook a task of model validation, because now that training was done, now that scenarios were generated, we undertook the exercise of model validation, and model validation was done against UNR 155 because that is the industry baseline. And as you can already see that the generated threat scenarios were quite aligned, or were matching to the Annex 5 of this document. So again, something again encouraging to understand that if generative AI algorithms have to be implemented for threat modeling, the one thing uh, from our experience is model validation. It has to stay as close to regulation, or to the standards document, and this is one of the ways to bring it closer. And finally, the next step that we did was to use again the regulation 155 document to understand what kind of security controls. So now that we determined the threat scenarios and aligned it with regulation 155, we were again able to use a similarity search pattern within R155 to nail down exactly which mitigation measure was that threat scenario aligned to. So in totality, and then we integrated this application of GenAI within our platform, within our security application tool called CRISKLE. This is a cybersecurity platform to conduct risk assessments and manage your cybersecurity vulnerabilities throughout the product lifecycle. And this is the system input that we gave to the BERT algorithm. So we gave it a system name, we gave it an asset name, we gave a proper cybersecurity goal and objective. We gave it a sequence of WP29 indicators, a sub-scenario, a threat type. So in totality, this is what the APIs basically were sent to the OpenAI GPT 3.5 model. It used technology RAG concept and generated threat scenarios. And this model is now integrated as part of our tool chain for performing risk assessment. So we now have embedded section within our tool chain, especially calling out generative AI and how it can help security analysts or engineers who are conducting these assessments day in, day out, to move away from those Excel-based static threat scenarios, which are limited to 30 or 40 drop-down menus, and basically look at what more and how intelligently can we offer some more constructive knowledge to the system engineer. Because bear in mind, it goes back to my point that not all cybersecurity professionals are system professionals, and not all cybersecurity professionals are safety professionals. So this will offer them a wide area of expertise at the same time, offer them a good knowledge in case they were not knowing this before. And it opens a lot of opportunities as well. So after the integration, and this is one of my final slides for today's presentation. So we began from an Excel-based exercise. Now we have a generative AI-based application which generates threat scenarios based on systems input. It offers assistance. It is not taking away work from engineers. So it is a complementary thing for the engineer because we can't have generative AI take the center stage in performing risk assessments. There should always be a human oversight, and this is the point that I want to labor again. The point was to understand benefits of using generative AI with consistent human oversight. And of course, using these mechanisms, you can reduce your overall time and cost when it comes to performing risk assessments. And therefore, in totality, that moves away your Tara document from becoming a static document to a more dynamic document. It has the capability of generating, threat scenarios automatically, or based on the model that you have trained. It can also offer you assistance in mapping the relationship between threat scenarios and mitigations, and of course, has significant potential of impact on potential, on like business productivity overall, and takes it one step beyond 155, because we are looking at a wide area of attack surfaces, wide area of threats, and a wide area of assets, something which is not part of 155 as is just a baseline. So that was, in a nutshell, uh, my talk on where we started the project from, and how we used several tools and technologies in this space of checking the feasibility of generative AI in automotive cybersecurity threat modeling, and integrating this now as part of our product offering, and finally realizing the benefits of this one. So I'll hand it over to Gani uh, for further. Thank you.
Nice. Yeah, thanks, Saket. Fascinating presentation. Thank you very much. As I said, I think some of the potential of what we're unlocking with this technology is interesting. I do want to open up the stage to the audience for questions. So I guess we're going to take those in the chat. If you have any questions, please feel free to ask the questions and then we'll pose them. Now, whilst we do that, maybe get the ball rolling. I wanted to ask a question around the adoption of AI, and how do we, even in this context, how do we do it in a safe way? And how do we trust the AI technologies we're using here to use in, I'd say, sometimes safety critical applications?
Yeah, so I think that's the next logical task. I mean, now that we have understood that it is feasible, it is possible to generate meaningful scenarios and meaningful ways of performing risk assessment, but then we didn't evaluate, um, firstly, whether the outcome of that model was, first of all, trustworthy. Can it be trusted? Is it acceptable? And so, yes, I think the next leg of work will look at two things mainly: privacy preservation technique of making sure uh, that this model will be used by a lot of companies in the market, because we are tooling services providers. So we have to make sure that our models are not only safe and secure, but we'll have to make sure that privacy is a big concern, so that one company doesn't lead to, information doesn't lead to be shared from one company to the other. So how do you make sure that that privacy angle is addressed, and also at the same time to evaluate the safety or the trustworthiness of this algorithm itself, so that tomorrow, if you are able to use this same algorithm, will it give you the same response tomorrow, or will it change? So understanding the trustworthiness behind, and the reasons. So we call them explainability, or the explainable AI, the concept of explainable AI. So I think mainly around two things. One is trustworthiness. Can it be trusted? And second is, can you please explain yourself? Why did you generate this kind of response? So I think these are the two things which will be explored over the next few months by us.
Yeah, very good, Saket. I had maybe a question. I'm still waiting for the audience members to pose questions. Please feel free to do so. But I had one around. You talked about reducing labor costs. Where's the in the context of what we're doing here with the CRISKLE tool and the philosophy of what we're developing?
Yeah.
What's the role of an engineer going to be now if they're not generating the threat vectors and the TAR and the HARA? What do we do as engineers, and what where do we still add value?
Yeah, so I think great question. I mean, today I have done many risk assessments myself over the past couple of years. So it's a meaningful exercise to do in Tara, because you or in rather in Excel sheets you are confined with some preset values, preset documents that actually come from these regulations. But that doesn't directly translate into productivity, because then the engineer is just choosing or selecting one of the other menus within the Excel file, and therefore is confined by the knowledge that he or she will get from an application like generative AI. So as I said in my presentation, it actually puts the focus or emphasizes the engineer to go beyond just thinking about security, but actually think about systems context, think about safety context. And this is an area that will tell the engineer, oh, I haven't thought about that already. This is a new thing for me. So I now need to talk to the safety teams. I now need to talk to the systems teams once again. So I think encouraging people to think in a systems perspective is good for a domain like cyber, because we are talking about cyber physical systems, and therefore the whole application of generative AI is not only a human oversight to check consistency, but actually to also encourage people to go beyond cyber and think about systems and safety at the same time.
Brilliant. Saket, thank you very much. We are bang on time. I really appreciate your time. Thank you, and a great presentation.
Thank
Just
you.
for the audience, just to let you know, our next tech talk is on June the 19th of June at 12 p.m. And we'll have Stewart Edmondson from the UK Electronic Skills Foundation with a very interesting topic around the current skills landscape, how electronics needs to be focused, and how we need to grow this whole area that we're all involved with to make sure that we can really flourish in the UK ecosystem. So 19th of June at 12 p.m., Stu Edmondson from the UK Electronic Skills Foundation. And of course, we have the AESIN Conference on the 11th of July. If you haven't registered, you should be registering for that. It's a fascinating day. We've actually filled the speaker slots. We're actively promoting that now. So please get onto the website. Chris has kindly shared that on the chat and register on that. We really want to encourage an inclusive philosophy behind the conference. We want you to invite colleagues, friends that you would normally not have coming to the conference to come and see what it's all about and what the industry is about. So get the word out there, bring colleagues, friends that you think would enjoy the conference to the event as well. So we look forward to seeing you there. So with that, again, Saket, thank you very much. Really
Okay.
appreciate your talk. And we will all see you soon at some future ASIN event.
Yeah, thank
Thanks
you.
very much.